Hello everyone, I'm Chen Lei. Today I will talk about our work Sentiment-Aware Neural Machine Translation. The motivation of this work is that some words actually have both positive and negative sentiments, and they can be translated into both ways, but the current AMT system can only generate one of them. For example, the word proud can be interpreted into both positive and negative sentiments. The sentence "he is proud" can be translated into both ways, either positive, which means he is very happy because of something good, or negative, which means he is very arrogant. But if there is context in this sentence, like he's so proud that nobody likes him, then the sentiment is very obvious. So there's only one way to interpret this. So the problem we are trying to tackle is how to generate both sentiments when the sentence do not have sentiment-bearing context. And according to a linguistics paper here, there are actually 110 such sentiment-ambiguous words, and we will be focusing on these 110 ambiguous words in this work. Just to emphasize the difference, we are trying to solve this case where the sentence is ambiguous and there's no very clear sentiment-bearing context. And for sentences like this, where there's already a very clear clue of the sentiment, there are actually existing works to show that current AMT system can preserve the sentiment in such cases. So our approach is a two-stage pipeline. First, we train a sentiment classifier to get the sentiment labels of all the AMT training sentences, and then we propose some new methods to incorporate these sentiment labels into the translation models. So the first part, to train a sentiment classifier, we fine-tune BERT to do the sentiment classification, and we fine-tune BERT on the training set of these two data sets, and we also do some evaluation on the three test sets, and here are the results. So we will use this sentiment classifier to annotate all the AMT training data. And second part, we propose three simple methods to incorporate the sentiment information we get from the sentiment classifier into the sequence-to-sequence model. And these methods are only applied on source sentences containing these ambiguous words. So if the sentence do not have any of the ambiguous words, we will not be using these methods. So the methods is, first method is the add label method. So it's very simple. We simply prepend the sentiment label to the front of the sentence to indicate the sentiment of the translation. So for example, if the training sentence is "he is so proud that nobody likes him," the sentiment classifier will generate a negative label, and then we just prepend the negative label in front of the sentence, and then we input the whole thing into the sequence-to-sequence model for training. And the second method is insert label. So when we are doing prepending the label in front of the sentence, we are actually forcing the model to infer which words are ambiguous. So in order to give the model a stronger clue, we actually insert the sentiment label right before the ambiguous word. So the model now actually knows which words are ambiguous because that's the word after the sentiment label. So these are the simpler methods. The third method is called valence sensitive embedding. So the idea is that we train two different sets of embedding vectors for every ambiguous word in our list, and then we will use the corresponding positive or negative embedding based on the given sentiment label. So for example, the word proud here, if the sentence has a positive label, then we will use the positive embedding in training. Otherwise, we will use the negative embedding in training. So during training, the sentiment labels come from the automatic annotation from the trained sentiment classifier. And during inference, the user can actually input the desired sentiment label and generate the corresponding translation. So for the sentence "he is so proud," if the user inputs positive, then the generated translation should be positive sentiment. Otherwise, if the user inputs negative label, then the translation should be negative. Next, we will talk about our experiments. The training data is actually extracted from these three publicly available corpora, Multi-UN, TED, and AI Challenger. And we will annotate the sentiment of all the source sentences using the trained sentiment classifier, and we will use this corpus to train our model. And for testing data, first we have this contextual test set. The contextual test set is just extracted from the previous training set, and it has a total of 9.5k sentence pairs. And the thing about this test set is that the sentences in this test set actually have sentiment bearing context. So the purpose of this test set is actually to validate that our model can preserve the sentiment when there is already a sentiment bearing context of the sentences. Next, we have an ambiguous test set. So this is the more important one, because in this test set we actually manually construct all the sentences, and the sentences in this test set do not contain any sentiment bearing context, and the sentences can all be interpreted in both sentiments. And then the construction of the ambiguous test set is that we actually ask bilingual human annotators to write the English sentences containing the ambiguous words in our list, and then they are asked to write the sentences such that all the sentences can be interpreted in both positive and negative valence. And we will remove those sentences that are already appeared in training or development sets. And we will also ask a third bilingual annotator to check and remove all the sentences in this test set if the sentiment can be easily inferred from the context. And after all this process, we get a quite small ambiguous test set with 120 sentences. So the purpose of this ambiguous test set is to check whether our model can generate corresponding translations when we input the sentiment labels in inference. And for evaluations, we have several different metrics. The first one is sentiment matching accuracy. So the idea of this matching accuracy is that we generate two translations for each ambiguous test sentence using the positive and negative sentiment labels respectively. So ideally, the generated sentences should be positive or negative corresponding to the given sentiment label. And then we will ask bilingual annotators to annotate the sentiments of the translations. And we will take the majority annotation as the correct label for each sentence. And then we will consider it is a match if the generated translation is the same as the annotated sentiments. So my example is, for example, if I input positive label for the sentence "he's so proud" and generated this translation, and it is a match if the generated translation is indeed positive as annotated by the human annotators. So some details about this matching accuracy is that the sentiment annotation only considers the sentiment of the translations and not the translation quality. We will deal with translation quality in other metrics, and some ambiguous words are actually missed in the translations, and so they make the translations neutral in sentiment. Such sentences are not counted in neither positive or negative. So this is the results. For the sequence-to-sequence baseline, there's only one translation generated. So the translation will be the same because it for both positive and negative, because it can't really taking a sentiment label. Yeah, so it's the same translation. And actually, this baseline here, we can see the negative accuracy is higher than the positive accuracy, because in the ambiguous test set, like the more ambiguous sentences tend to be negative. For the sequence-to-sequence baseline, it actually on the ambiguous test set, the sequence-to-sequence baseline will generate the translation that is more commonly seen. So, for example, if the word stubborn is more commonly used as a negative word in the training set, then in the translation it will just generate the negative translation, because there are more such cases in the training set. So this is for the sequence-to-sequence baseline. So we can see for majority of the words in the ambiguous test set, they are more commonly used as negative. So negative matching accuracy is actually higher than the positive one. And we can see after using our proposed methods, there's an increase in the sentiment matching accuracy. Yeah, and for the contextual test set, we randomly sample 120 sentence pairs and ask human annotators to annotate the sentiment of the English sources and Chinese translations respectively. So for the contextual test set, there's already a sentiment in the sentence. So we are not trying to generate different translation of the same sentence. We just generate one translation and see whether the generated translation will preserve the sentiment from the original sentences. The next metric is blue. So it is to see the translation quality. And we actually ask the bilingual translator to produce the reference translation for the ambiguous test set. And there are actually two sets of reference translations, one each for the positive and negative sentiment. So each sentence in the ambiguous test set has two reference sentences. One is in positive sentiment and the other is in negative sentiment. And here are the results. We can see there's an increase in blue score after we use the three proposed methods. And for contextual test set, we can see the blue score generally is, I would say, is around the same. So it actually means our methods will not affect the model performance on the case where the sentence already has a sentiment bearing context. Yeah, and we observe that the blue score on the contextual test set is generally much lower than the ambiguous test set, and the main reason is that the sentences in the contextual test set are much longer and more difficult to translate. Yeah. And then the last metric is actually sentiment word translation performance. So the idea is that we evaluate on the word level translation performance, including precision recall and F1, and these evaluations are done especially of the sentiment ambiguous words in the test sentences. So we do not care about the accuracy of those not ambiguous words. So we only measure the accuracy of the translation of these sentiment ambiguous words. We use fast align to get the alignment between reference translation and generated translation. And then we use the alignments to get the reference translation of the sentiment ambiguous word, and then we do the evaluations. And for the contextual test set, each sentence is associated with a sentiment label as predicted by the sentiment classifier. And then for the ambiguous test set, each sentence is tested against both sentiment valences. So actually it's the same as the previous evaluations. Yeah, so for contextual test set, there's one translation generated. And for ambiguous test set, each sentence has two translations generated. And here are the results. You can see on the contextual test set, the results are not so much difference, but on the ambiguous test set, there's a significant increase in results, especially for the VSE method. Yeah, and some analysis here. Yeah, we already mentioned this point, right? The performance of negative sentiment translations is better than that of the positive translations because those negative cases are more commonly seen in the training set. Yeah, so the model can actually learn better of the negative valence compared to the more rare positive valence. Yeah. And here are some examples of the translations generated. So the first example, she is so stubborn. So the sequence-to-sequence model will just generate the more common translation, which is negative sentiments. But using our proposed methods, it can actually generate the positive translation as well, which means resilient in this case. Yeah, and there are some other examples as well. And this work was actually rejected by EMLRP, and so I think it's good to summarize the reasons of rejection here. So the first reason is that the reviewers think that our methods are not novel enough. And the second reason is they think the ambiguous test set is too small, which is true because it only has 120 sentences. And another negative comment is that they think the focus of this work is too narrow because we only did experiments on one language pair, which is English to Chinese, and we only dealt with 110 ambiguous words instead of dealing with the general lexicon choice, but depending on sentiment problem, which is more general but also broader. So that's the end of the introduction. Thank you.